Can you guys see the screen?
Yes, sir.
Now you're right. We are done with method of preparation and also the physical properties. Now we are going to do chemical properties. Huh? Chemical properties of, first of all, haloalkenes, and then you will look at the chemical properties of halorine. So write the heading. Chemical properties of haloalkenes. Now, in chemical properties of haloalkenes, basically we are going to look at the reactions. What type of reactions haloalkenes are going to show. Please write with me. Haloalkenes primarily show the following types of reaction. The following reactions. Now, what are the reactions that they are going to show? So, number one is nucleophilic substitution. Second is elimination reaction. And the third one is reactions with metal. Okay. These are the three types of reaction that we have to study. In nucleophilic reaction, that is the major portion in haloalkane halorine, and that is the longest portion also. After that, elimination reaction is just one reaction. The reaction with metal is just 2-3 reactions. Okay. The majority of the part that we are going to deal with is nucleophilic substitution. We are also going to learn about mechanism. Okay. So you will write now the heading nucleophilic substitution reaction. Nucleophilic substitution reaction. Now, nucleophilic means the attacking reagent is going to be electron rich. Yeah. That is why it is attacking on the nucleus. Why on the nucleus? What is the charge on the nucleus? Tell me, guys, Rishita and Harsha. What would be the charge on nucleus? Positive. I mean, is it positively charged or is it negatively charged? The nucleus is positively charged because of the protons present in the nucleus, right? So that is why our nucleophile will be electron rich so that it can attack the nucleus, right? So it is going to attack what? It is going to attack the electrophilic centers. Nucleophilic reagent is going to attack on electrophilic. So what is a nucleophilic substitution reaction? Write with me. A reaction in which a group of substrate, in which a group of substrate is replaced by a nucleophile. It's called nucleophilic substitution. denoted by we have S, and in subscript we will be having N, Sn. Now, what is substrate? Substrate is generally the organic part, है ना? Organic reactant molecules. Substrate क्या होता है? Substrate is the organic reactant molecule. Okay, so in this case here in this chapter it is Rx, alkyl halide. This is our substrate. Then nucleophile. Nucleophile, it is made up of two words, nucleo. This tells about nucleo, representing nucleus, and phile is representing loving. Okay, so that is why if it is nucleus loving, that means you can say that these are going to be electron rich species, and attacks on majority of the time it will attack on the carbon atom. So the generic reaction of nucleophilic substitution or SN will look something like this. We will have R X plus nucleophile. The nucleophile will have lone pair and it can also have a negative charge. Okay? So it is going to attack on the alkyl. It will replace the halogen and you will get X negative. अब देखिए एक यहाँ पे थोड़ा सा छोटा सा कंसेप्ट इस्तेमाल होता है which is slightly hinting towards the Lewis acid base theory. So in Lewis acid base theory, the Lewis base is a electron rich species. जैसे NH3 को वो base कहते हैं Lewis. Why? Because NH3 is going to have a lone pair electron. So anything that is electron rich, it can be called as a base. Okay. Now, if you look at the nucleophile, it is also having negative charge. If you look at the X negative, that is also having a negative charge. So basically, one base is replaced by another base. Okay. Next one, लिखिए. What is happening in SN? Please write. In SN, one base is replaced another base. Okay. The incoming base is a new base that is incoming. The incoming base is called nucleophile. I'm just representing as Nu, and the outgoing base is called leaving group. Okay. So it is important to remember these words also, because we are going to use these words while we are studying the nucleophilic substitution mechanism. Okay. Leaving group, nucleophile. So leaving group is a new word for you guys now, and in nucleophile हम लोगों ने देखा. So this is nucleophile is the incoming base, leaving group is the outgoing base. Done? Harsha and Rishita?
Yes, sir.
Yes.
So let me give you some problems. You just need to identify what is the nucleophile and what is the leaving group. ठीक है? I'm giving you the complete reactions. ठीक है ना? देखिए, this will be the nucleophile and this will be what the leaving group. ठीक है? Leaving group हमेशा कहाँ मिलेगा आपको? It will be in the products. Nucleophile will be always in the reactant. ठीक है? You need to identify. अब यहाँ पे आप लिखिएगा ऐसे nucleophile, यहाँ पे लिखिएगा क्या? Leaving group Lg. ठीक है? Nucleophile. So for this case, what is the nucleophile? Cn negative. Make sense? Yes or no? Please tell me. And the leaving group is I negative. जी बताएं. Make sense? Irshita and Harsha.
Sir, shouldn't we get
ठीक है ना?
Br negative?
No, no, एक second. Harsha, one second, please.
So, like, shouldn't we get Br negative according to the reaction?
Sorry, my bad. Yeah. We are negative. We are negative. G. Thank you. Next, देखिए, if you have Cl plus, let's suppose you have NO2 negative. देखिए, इस तरह के कोई सवाल लेकिन आएंगे नहीं, ठीक है ना? बस आपको एक बार प्रैक्टिस हो जाए that what things can be, you just get acquainted with this type of reactions. Please do this and send the answers on my WhatsApp once you're done. तो बस एक चीज आई वांट टू टेल यू गाइस, बाकी भी देख लें, बाकी सब आपने सही किया होगा, एफ बी आर ठीक है, ठीक है, and here also A negative, alpha negative, C negative, we have H negative, B negative, so बस एक चीज यहाँ पे देखिएगा, this NaOH, even though I have written NaOH, but whenever you add NaOH, I mean this reaction will be done in aqueous medium, XC solvent में होगा. So NaOH, it is not present as NaOH, no, it is present as Na positive and OH negative, right? Make sense? This one please tell me, Rishita and Harsha.
Yes, sir.
So you can see that OH negative is the nucleophile. Okay, so for the case when you have ionic compounds, then in that case you will dissociate them and you will see that what is the anionic part, and the anionic part will be counted as the nucleophile. Does that make sense? Yes or no, please tell me. Got
Yes,
it?
sir.
Yes.
Okay. Otherwise everything is correct. Okay. Now right next, let us see what is happening in actions, and then we can talk about their mechanism. If I look at the reaction, generic reaction is Rx plus nucleophile is going to give you guys RNU plus X negative. That means what should happen? This red bond here, that is between the R and X, that is alkyl and the halogen CX bond, this should be broken, and there is a new bond that is RNU, it is being formed. Does this make sense? This is formed and this is broken. Now this is now we are doing mechanism for the first time itna detail mein. So this is the like the first thing that you should know about a reaction, that what bond is getting broken and what bond is getting formed. तो जो सबसे पहला initial step है किसी भी reaction को याद रखने के लिए, that is what is broken, which bond is broken and which bond is getting formed. Now what is happening, I will write it. Rx bond breaks and RNU bond, it forms. So these two things can happen either in single step or they can happen in two steps. Does that make sense? इसमें please tell me. या तो ये एक बार में ही हो जाए या तो दोनों अलग लो, पहले RX बॉन्ड टूटे उसके बाद RNU बॉन्ड फॉर्म, और RX बॉन्ड टूटता रहे और RNU बॉन्ड फॉर्म होता जाए. मेक सेंस? ये सुनो, दो तरीके हैं इसके, दो तरीके लॉजिस्टिकली हो सकते हैं. क्या ख्याल है हर्षा एंड ऋषिता?
Yes, sir.
It can happen in single step or it can happen in two steps. ठीक है. अब जब अगर सिंगल स्टेप में होगा तो ध्यान दीजिए, देखिए, if it is happening in single step, that means what would happen, you have R, you have nucleophile plus Rx and it is going to give you RNU plus X negative, है ना, एक स्टेप में, ठीक है, एक स्टेप में. But if it is happening in two steps, अच्छा, यहाँ पे if I want to show the arrows, I will show the arrows like this. The nucleophile is going to attack on the R because it is electron rich. It will be having some lone pair electrons. These bond will be gone with X negative X. That is why X is getting a negative charge. In 2 steps, what should happen? First of all, the Rx bond will break. So it will break like this. Rx. It is going to give you R. Now where the electrons will go, which is more electronegative? More electronegative element is halogen atom for sure. So halogen will take the electrons and the R will get a positive charge plus X will get a negative charge. Now we have R positive, that is a carbon atom with a positive charge. And in the next step, what will happen? The nucleophile with its electron-rich component, it will come and it is going to attack on the R positive, right? And we will get RNU. Okay, so this attack is going to happen like this. Does this make sense? Yes or no? Please tell me.
Yes, sir.
ठीक है. अच्छा, अब यहाँ पे ना we will talk about the rates. See, this is one of the problem of teaching organic chemistry. That is the part 2 before part. Now you don't know anything about rate of reaction. Chemical kinetics we have not done till yet because it is in the first, right? But थोड़ा सा हम आपको ना थोड़ा सा आपको फील कराने की कोशिश करते हैं like what we are talking about. If you look at the single step, then we have nucleophile and we have alkyl. We have 2 components, right? We have 2 reactants which are taking part reaction and फिर product बनता है एक ही step. That means if I increase the concentration of nucleophile, if I increase the concentration of nucleophile, there will be a lot of nucleophile and a lot of nucleophile is going to attack the alkyl halide. So the reaction will be faster. That makes sense? If I increase the amount of nucleophile, then
Yes, sir.
there will be a lot of which is going to attack and get the reaction faster. Similarly, if I increase the amount of haloalkane also, then also the reaction will be faster. So these type of reactions, here you can say that it is bimolecular, that it is depending on the concentration of both nucleophile and alkyl halide. यहाँ पे जो rate equation बनता है ना, तो rate it is proportional to the concentration of nucleophile as well as the concentration of haloalkane. Now, when we have multiple steps in a single reaction, that is, when you have it in single reaction, उसको हम बोलते हैं elementary reaction. एक step होता है. जब एक से ज़्यादा step होता है, उसको बोलते हैं complex reaction. So in complex reaction, now we have to see which is the slowest. Why slowest? Please see. If I have, let us suppose, a t-shirt, and let us suppose a shirt, and let us suppose a jeans. T-shirt takes 5 minutes to dry up, shirt takes 10 minutes to dry up, jeans takes 15 minutes to dry up. What will be the total time taken for the drying of all of these 3 clothes? Tell me, guys. What will be the total time taken?
15.
Rishita, what about you? Total time taken to dry up?
15.
15? Pakka? 15?
If it's simultaneous, then yes, sir, 15.
Sorry, what did you say? Simultaneously,
Yeah.
obviously, simultaneously only. Simultaneously only. So, so you can see that it is depending on the slowest one. Similarly, these 2 steps reaction, it may seem that Rx is the first step and attack of nucleophile is the second step. But this first step and second step will be only for a couple of thousand molecules, right? After 1,000 molecule has been formed, the first step and second step will be taking place simultaneously because the first step se 1,000 molecules mile, they will be doing the second step and rest of them will be doing the first step. That makes sense because we'll be having millions of molecules. So when we are having millions of molecules, then we can say that this is, if I take a single molecule, then the RS is going to cleave first and then the nucleophile is going to attack the alkyl. But in a million molecule, these reactions, both of these steps will be happening simultaneously. That makes sense? जी बताएं. Does that make sense? Yes or no? Please tell me, Rishita and Harsha.
Yes, sir.
Yes, sir.
Now you tell me which one will be the slowest, the first step or the second step? Which would be slower?
The first step.
Okay, reason, Rishita?
Because
Why
it
do you think
takes
so?
more.
Mic off हो गया आपका.
It takes more energy
It takes
to separate. more energy to separate the R and the X, the
break the bond,
component.
break the bond, है ना? Break the bond, right?
Yes, sir. Like the bond.
Break the bond. Yeah, correct. Harsha, that makes sense, yes or no? It will be difficult to
Yes.
break rather than to form, because also one more thing you can see. If you look at the first step, we are going from a neutral state to charge. To charge to, it will be what? Unstable. Will be difficult to go from stable to unstable. But if you look at the second step, we are forming a neutral species. So second step will be very quick, because nucleophile is going to have an electronish lone pair, or it will be having negative charge, and carbon is having a positive charge. So they will attract each other and they will form the RNU bond very easily. So here we can say that the R, or the rate, it is directly proportional to the concentration of only one reactant, that is the haloalkane. And in this way, we have divided the SN into two types. Details are coming. SN into two types. Here, this SN will be what? SN2. That means nucleophilic substitution bimolecular. And this is SN1. That is nucleophilic substitution unimolecular. So this 2 is for bimolecular, this 1 is for unimolecular, but the number of steps is just the opposite. In SN2, the number of step is 1. In SN1, the number of step is what? 2. ठीक है? याद रहेगा? याद रखने की जरूरत नहीं, याद हो ही जाएगा. Now you will write types of SN.
Can you scroll up once?
Yeah, sure.
Thank
Types of SN. We have SN1 and we have SN2. सबसे पहले हम लोग SN1 पढ़ेंगे, उसके बाद हम लोग पढ़ेंगे SN1, उसके बाद SN2. ठीक है? Types of SN, SN1, SN2. Write the heading SN1. It refers to unimolecular nucleophilic substitution. The pattern in which rate depends on the concentration of substrate that is haloalkane in this chapter, haloalkane only is known as SN1. अब यहाँ रेट होगा डायरेक्टली प्रोपोर्शनल टू concentration of haloalkane, and rate equation we will understand this later, will be proportionality sign बताएंगे. तो एक proportionality constant है, इसको rate constant बोलते हैं, multiplied by Rx. And we call, अब ये भी चीज जैसे order is equal to 1, ठीक है, and molecularity of this reaction is also equal. Next you will write mechanism. mechanism. We have seen that it occurs in 2 steps. It occurs in 2 steps. Okay, what are the 2 steps? See, carbon. We have halogen. This bond is going to break. This will be slow. And I've also shown reversible because if halogen atom attacks the carbocation, then it will form the halogen. Then we will get carbocation and it will be having 3 bonds. And when we will be having 3 bonds, it will be a planar structure because the steric number has now been reduced from 4 to 3. Now the trigonal planar type of structure is present, which is sp2. And sp2 is what? Trigonal planar. This is a carbocation plus X negative. So let me do one thing. This is 1. This is 1 number, this is 2 number, this is 3 number. Okay. And after breaking, we have got this as 1, 2, 3. Just to denote the groups that are attached. And I'm not labeling any groups, but A, B, C करके मैं label कर दिया. Next step is attack of nucleophile. अच्छा इसको इस step में आप देखिए थोड़ा सा space अगर आपके पास है, I can तो just drag it down. Otherwise, you can name this step as number 1. Breaking of CX bond, or we can call this formation of carbocation. Formation of carbocation. ठीक है. Second step में we can call this attack of nucleophile. Attack of nucleophile. Now we have carbocation, which is like this. I mean that's एक काम कीजिए. If you don't write now, just look. 2 and 3. ठीक है. This is going to have a positive charge. अच्छा. देख रहे हैं ना ऋषिता, हर्षा? Not writing down. जी tell me.
No.
हाँ ठीक है. पेन छोड़ दीजिए, ध्यान से. In carbon atom, what is the electronic configuration? It is 1s2, 2s2. And in the ground state, it is going to be like this. अच्छा एक इलेक्ट्रॉन यहाँ से निकल चुका है. अच्छा चलिए इसको मैं पहले से कर देता हूँ. 1, 2, 3, 4. But we know that 1 electron has been removed. ठीक है. तो यहाँ पे आपके पास कार्बोकेटाइन है ना, एक पॉजिटिव चार्ज, एक हम यहाँ से इलेक्ट्रॉन निकाल देते हैं. ठीक है. Let me remove this electron. Now the hybridization will take place and you will get what? sp2. Now this is a vacant orbital. Can you see that? This is what?
Yes.
Pure p. This is pure p orbital, which is vacant. And the same pure p orbital will be vacant here that I am representing like this. Okay. What is going to happen now? The nucleophile is going to come and it can now attack on C. Pure P, pure P orbital does not have any electrons, so the nucleophile can come and it can attack on both the lobes, either lobes, not both, but rather either lobes. So you have nucleophile. It can take, let us suppose this blue pathway to attack here, or it can take red pathway to attack here. And basically what pathway it is going to take? It is going to take both the pathways because we will be having millions of molecules. 500,000 will be attacked from the blue pathway, 500,000 will be attacked from the red pathway just by the, just like by the virtue of probability. Make sense? Yes or no, please tell me. दो जगह अटैक करने के लिए millions of molecule है तो 50-50% होगा. क्या ख्याल है?
So both of them take up the same orbital, right?
हाँ, both of them are the part of same orbit, but the lobes are in the different directions.
Okay.
है ना? अब यहाँ पे क्या होगा? We will be getting two products, one for the blue pathway and the other will be for the red pathway. Okay. Now in blue pathway, what is going to happen? Carbon atom, and you will have nucleophile behind, and you will have 1, 3, 2. Does this make sense? Yes or no, please tell me. Make sense, na? Yes or no?
Yes.
Because
Yes,
it will
sir.
again go back to tetrahedral case, है ना? इसको अगर हम थोड़ा सा like if I keep this same here and I rotate it a bit, then आपको ऐसे 1, 2, 3 भी दिख जाएगा. Like थोड़ा सा rotate कर दिया अगर molecule को तो, ठीक है? I'm writing 1, 2, 3 only for the sake of comparison with the earliest molecule, the reactant. Now, if I am going to attack from the red pathway, then I will get something like this. We'll have the carbon atom here and carbon atom here. The bond with nucleophile will be somewhere here like this, and the other bonds will be 1, 2, and 3. Now, if you look at the molecule that we have produced from the blue pathway and the molecule, both of these will be formed. ठीक है ना? इन दोनों ही के formation होगा. If I compare this with the reactant, then I say that the blue product is inverted. Make sense? Invert हो चुका है. And in the red one, the red product that we are having, this has retained the configuration whatever was present for the initial starting material. इसको हम लोग बोलते हैं, इसको बोलते हैं retention. The inversion will be also 50% and retention will be also 50% because probabilistically 50-50%. And when you are going to have, because both of these products will be formed, you will be having a mixture here, and this mixture, let me just take this retention and put it here. And this mixture is known as racemic mixture. Okay. This is only going to happen if you have 4 different, I mean, other than the leaving group, if there are 3 different, what I can say, groups attached on the carbon atom, then not it is possible. That is the case of stereoisomers. जब 4 अलग-अलग रहेंगे तभी होगा. But this is a characteristic of what SN1, that we get racemic mixture, 50% inversion or 50% retention होता है. ठीक है? Please copy this down.
So the ones you marked as 1, 2, 3, so they should all be different.
I mean, when they are all different, then we define this inversion and retention. Generally, इसको inversion or retention नहीं कहेंगे. जब if you have 1 and 1 are same, then in that case, I mean, it is not going to be a chiral carbon. But that discussion will come later on. But we are not just learning the properties of SN1. So in the properties of SN1, we are going to always write. We don't have to make it. We don't have to clear this up that 1, 2, 3 should be different. I'm just telling you guys. Okay? When you're writing the properties like difference between SN1 and SN2, for SN1 you'll write we get racemic mixture in which 50% inversion and 50% retention products are there. That's it. Make sense?
Yes.
ठीक है. The detailings will come later on. अभी हम लोग से properties पढ़ रहे हैं. ठीक है. And detailings about the chiral carbon, I teach that at the end of the class. जब सब सारे reactions हो जाते हैं ना उसके बाद. because that is completely separate. बहुत ज़्यादा relation नहीं है आपकी से. So today we'll be completing nucleophilic substitution of alkyl, I think so. Rishita, waiting for you. ठीक. ठीक है, हम लोगों ने पहले डिस्कशन से पढ़ा था ना कि अगर so if the step is fast, the second step is already fast. Make sense? Yes or no? Please tell me. So the rate is going to depend on the fastness of the first step. Make sense, Harsha and Rishita?
Yes, sir.
And the SN1, the first step, it is occurring via intermediate carbocation. So you write SN1 occurs via intermediate carbocation. Now, if we have a stable carbocation, that first step will be quicker, and then the complete rate of SN1 will also be faster. And this is a very characteristic line that I'm writing, complete for the all organic chemistry. Rate of any reaction, it is directly proportional to the intermediate. Okay, rather I should say stability of the intermediate. In this case, when I talk about the rate of SN1, then the rate of SN1 should be directly proportional to the stability of carbocation. Okay, of carbocation. Next step, sorry, next point that we are going to write, SN1 gives 50% inversion and 50% retention product. Okay, next line. The mixture with 50%, I'm writing I, आप लेकिन inversion लिखिएगा पूरा, ठीक है ना? And 50% R is called racemic mixture. And the process is called racemization. Process is called racemization. लिख लिया आप लोगों ने? हर्षा? Rishita is done. Waiting for Harsha. Okay. Right, next SN2. ठीक है, SN2 में लिखिएगा, it refers to Bimolecular nucleophilic. Substitution. ठीक है. The reaction which is the reaction in which rate depends on both.
So the mechanism is only of those two steps.
Sorry, what, Harsha?
The mechanism is only of those two steps.
For SN1, na? SN1 2 steps only. SN2 then we are going to look again at the mechanism. SN2 का अलग से देखेंगे. ठीक है. So we are writing the introductory part that we wrote for SN1 also. If you can compare. ठीक है. The reaction in which rate depends on both haloalkane and nucleophile. Is known as SN2. Directly proportional to the concentration of haloalkane and the concentration of nucleophile. The rate expression will be is equal to the rate constant multiplied by Rx multiplied by the nucleophile's concentration. The order in this case it is equal to 2. The molecularity it is also equal to 2. Now, then we will look at the mechanism. So this occurs in one step. So both breaking of CX and formation of CNU bond takes place simultaneously. The breaking of CX bond and formation of CNU bond takes place simultaneously. स्पेलिंग सही है मेरा simultaneously. टी होता है ना सिर्फ. Simultaneously. तो यहाँ देखिए जरा. अच्छा, अब आप लोग पेन छोड़ दीजिएगा, ठीक है ना. Write this point, breaking of CX and formation of CNU bond takes place simultaneously. अब आप लोग छोड़ दीजिए, पेन छोड़ दीजिए. ठीक है. कार्बन F halogen and we have 1 2 3. ठीक है. थोड़ा और अच्छे से अगर आपको बताएं. So this 2 will be rather I can say that it will be dash का मतलब जान रहे हैं, that it will be behind the plane. You know this wedge and ये पता है क्या आप लोगों को कि नहीं पता अभी? थोड़ा याद कीजिए, शायद हमने पढ़ाया होगा टेट्राहेड्रल स्ट्रक्चर जो होता है इन केमिकल बॉन्डिंग. याद आया कुछ निशिता? Yes, ठीक है. So you can see that this is in the on the plane and this dash is what behind the plane and this you can say wedge it is on the plane, sorry out of the plane. So एक ऐसा कोन टाइप का मतलब बनेगा and between the cone there will be a hollow space. I hope you can see that. Jasola, please tell me. मुझे समझ में आ रहा है?
Yes, sir.
ठीक है, अब देखिए. This halogen atom, it is electronegative. That's why it will be pulling electrons. It will be pulling electrons from the carbon atom and getting this as delta negative. The carbon atom will be delta positive, and that delta positive will be attracting the nucleophile. If I have a nucleophile which is negatively charged, now there are two ways. Either I can go that way. If I want to attack this way, no, where the halogen atom is present, if I want to attack in this plane, in this particular side, in this particular direction, then it will be very difficult. Why? Because the halogen atom is negative electron density. It will be having a large electron density around it, and that is going to repel the nucleophile. So inherently, what nucleophile has to do, it has to come from behind, and जो hollow था ना जहाँ पे cone का, it is going to attack from behind like this. Okay, so when this attack happens, so it will happen in this particular way. Now, as soon as this nucleophile is going to attack, this halogen atom is going to start to leave. ये bond अपना तोड़ने लगेगा, and we will get a transition state, we call it, which will look something like this. इसको स्क्वायर ब्रैकेट से बनाते हैं, इस वजह से आप मेरे स्क्वायर ब्रैकेट, बिग स्क्वायर ब्रैकेट, कार्बन एटम 1 2 3, ठीक है. We have the nucleophile. This so this bond is getting formed. I have denoted this in blue, and this bond is getting broken. That I have denoted it in red. And once the reaction has occurred, now what we are going to see, the nucleophile, it is attacking from behind. So nucleophile, carbon, and 1 2 3. ठीक है, plus X negative. So what is happening here? 100% inversion. Because the attack is happening from the backside. So बोलते हैं transition state. The mechanism makes sense. This one, Rishita and Harsha.
Yes, sir.
So the transition
Yes.
state is the intermediate.
Yes. No, it is not intermediate. Okay. थोड़ा सा फर्क होता है intermediate और transition state में. Intermediates are separable and they can be stabilized. Like if I add, for example, we had carbocation. Carbocation is positively charged. If I add an electron donating group, so that positive charge will be stabilized. But transition state, they cannot be stabilized. The transition state क्या होता है? बस it is the highest energy state in the system. Imagine nucleophile NaOH मान लेते हैं, है ना? Sodium hydroxide, haloalkane. Let us suppose we are going to take bromopropane. NaOH also is stable. Bromopropane is also stable. But when you are going to mix them, OH negative and carbon will be having a positive charge. So now some reaction can happen. When the OH negative is going to come near the carbon of CBr bond, then what will happen? This carbon will be making a bond with the OH negative and losing the Br. Is in the most unstable state. उसी को transition state बोलते हैं. The highest energy state possible. Now why do we talk about transition state? Because वो बाद में केमिकल, मतलब अब तो आपका बाद में पहले आता है, केमिकल काइनेटिक्स में पढ़ते हैं. Like what is the highest energy possible, और उतनी एनर्जी देनी पड़ेगी आपको सिस्टम में. If the system does not have that much energy, either in the form of heat or in some other form, then that reaction is not going to occur. ठीक है, तो ट्रांजिशन स्टेट का बस वही इंपॉर्टेंस है. Nothing else. It is just there. We are not going to learn about transition state. कुछ नहीं पढ़ने वाले उसके बारे में. Carbocation, although we are going to learn about carbocation because carbocation is going to affect the carbocation stability is going to affect the rate of SN1. So when we will be learning the rate of SN1, then we are going to learn about the carbocation, not about transition state. Okay, this is just a हाईएस्ट एनर्जी स्टेट पॉसिबल ऑफ अ सिस्टम, और कुछ नहीं। ठीक है, ऐसे देखेंगे हम लोग कि हाउ इट विल डिपेंड, SN2 जो है वो किस पर डिपेंड करेगा वो भी देखेंगे। Raise your hand once you're done. If you're done. Right, in SN2, the attack of nucleophile is from behind. Okay, therefore, rate of SN2, the rate of SN2, it will be bulky groups attached on the alpha carbon. Alpha carbon कौन सा होता है? This carbon atom is attached with halogen. This halogen is the main functional group that we are having here. This carbon will be now alpha carbon, the most important carbon atom. If 1, 2, and 3 are small, then the nucleophile can easily navigate and it can attack the carbon atom. But if 1, 2, 3 are very large, then in that case, nucleophile will not be able to get inside that cone, the blank cone, because of the bulky groups, and the reaction will be slow. So rate of SN2, because it is happening from the behind, it is inversely proportional to bulky groups on alpha carbon. ठीक है, next you will write SN2 occurs via transition state and next is in SN2 we get 100% inversion product. Due to backside attack of nucleophile. Next, you write factors affecting SN1 and SN2. So the factors that are going to affect the SN1 and SN2 are three things. Two of them are quite obvious. That is, first is nature of substrate. What type of substrate we are having? We are going to look at the structure and the properties of substrate. Nature of, that is hierarchy in this case, nature of substrate. Second, we are going to look at the nature of leaving group. How good is the leaving group? And third, there will be also effect of solvent. What type of solvent you are taking? Effect of solvent. Okay, but these factors we are going to look at them in the next class.